Today we'd like to present an example of traditional settling ponds done well. In operations that have sufficient area, the recycling of the vast majority of process water can be achieved by utilizing a multi-stage pond system. Not all sites have the area for ponds or consistent makeup water or top-off water supply, or the area where ponds would be may be covering future reserves. In these cases, thickeners or clarifier tanks with automated flock dosing systems are utilized. And in some cases, where maximum silt and clay management and maximum water recycling is required, the thickener is followed by a recessed plate filter press. Today, we'd like to present an example of traditional settling ponds done well. In this case study, we have two parallel wash plants producing 200 tons per hour each, totaling 400 tons per hour of damp frac sand to the product pile. Based on the low turbidity and lower silt and clay content in the feed, the total water required is approximately 3,400 US gallons per minute total. We monitor this process water into the wash plant water manifold with a flow meter. The recycled process water is drawn from the corner of the final pond in this circuit, and water is introduced through high-pressure spray nozzles on the screen, with some direct-to-sump dilution water. The sand slurry is pumped to highly efficient hydrocyclones that recover the sand to high-frequency dewatering screens. A drip-free, damp frac sand product is stockpiled, and the clays, silts, and water exit the cyclone overflow and gravity flow to the opposite corner of the pond circuit. The tailings enter the far corner of the first settling pond. Because the tail slurry is moving through the pipes with high velocity, it's important that the first pond be wider and larger than the sequential ponds, so the slurry has ample area to slow down. Natural settling progression occurs with largest particles falling out of suspension first. Smaller particles settle in the secondary and tertiary ponds. Depending on the nature of the clay in the tails, the hue of the recycled process water will be affected. Use of flocculants can be utilized to promote faster settling process and to further clarify the recycled water. The ponds are interconnected by wide weirs, but as the flow passes through the narrower areas, the velocity increases, disrupting the continued settling for a short time. This is why each pond in series needs to be wide enough to decelerate the tail's velocity to continue the progressive settling process. It is also important that each progressive weir is on opposite ends of each respective pond. Between each pond, a separation dam, wide enough for a long-reach excavator to travel onto, is important for future access needed to excavate out the settled solids. A controlled spillover weir in the corner of the primary pond is important for significant rain events to provide a controlled and managed capture of excess volume of water. The controlled spillover weir provides a second function as well. When the operation is purposely halting sand production for preventative maintenance, top-up water can be added to the pond, and the organics floating on top of the water can be purged from the pond circuit. By utilizing a multi-stage settling pond circuit to this design presented today, the clays and silts can be best managed in the primary, secondary, and tertiary ponds, and the recycled process water can be reutilized from the final pond to provide the proper amount of water needed to sustain the high production rate of damp frac sand at the parallel modular wash plants.